moving on to 2-5. Linear models. A linear model is, first of all, linear means line, and model is what we use to find something else. So a model is an equation that we use in order to predict something else that might happen, right? And so we are going to be making these models today from the information you're given, okay? So first thing, though, we need to talk about is, of course, what they call correlation. So we're going to start there. All right, correlation is the strength of a relationship between X and Y values. So, for example, if I were to plot a bunch of data I'm given, and when I plot this on a scatter plot, right, and the dots are going in very close together in an upward motion, right? We call this a strong positive correlation. It's strong because the dots line up, right? And they're going in a positive direction. They're going up to the right. If those dots were a little bit more spread out, but still going in that, we would call this a weak positive correlation. Again, for it to be positive, as it goes this way, it's going up, or it's going up to the right. If we have those dots and we plot them and they're really close to being in a line but going in a downward motion, this is a strong negative correlation. And if we had it going, of course, in that downward motion, but a little more spread out, any guesses? Weak negative. And we have one more. If when you plot all those points, they're everywhere, and they don't look like they have any kind of line happening whatsoever, no correlation, exactly. I'm just going to put none, okay? All right, so obviously, if you can't tell already, we're going to be talking about scatter plots. We're going to be talking about trend lines. We're going to be talking about line of best fit, all those wonderful words, okay? And then we're going to do what we call a regression line. So we have lots going on today, lots and lots. So first, let's start with a scatter plot. Who can tell me what a scatter plot is? Okay. I guess, yes, they are points that you're plotting. A scatter plot, where do I get those points from? Data. Very good. From data, right? Okay, so let's start with saying I have some data. Now, this book likes to put the data horizontally instead of up and down. So I'm going to give you some data going this way. And let's go with, oh gosh. let's go with we'll put the year up here, and how much money they make per household, average money made per household. So let's say in 1940, the average household made $23,000. Oh. Let's say in 1960, they made $31,000. Let's say in 1980, they made $40,000. In the year 2000, let's say they made $42,000. And in the year 2020, let's say we made $47,000. All right. So now we're going to plot these on a scatter plot. Now remember, my top line or my year, this is my X value. So across the bottom, I'm going to have some dashes. And remember, you can have a break and start wherever you want, as long as you put a break in there. I'm going to call this first one 1940. I'm going to go by 20s, 1960, 1980. Here's 2000, 2020. All right, going up and down, I'm going to put a break here, and let's start at 20,000. Yeah, just a squiggle. And let's go here and go 40. Actually, let's go to 30,000. We'll go up by 10,000. So we'll say 30,000. And then I'll put another one and go 40,000. And we'll do one at 50,000. Okay, so let's go ahead and plot what we got. So in 1940, there was 23,000. So right about there, approximately. In 1960, we had 31, so I'm going to go just above 30. In 1980, we had 40,000. In the year 2000, there was 42. In the year 2020, we had 47. All right, so first of all, what kind of correlation do we have going on here? Strong positive, I agree. Okay, so now we are going to draw a trend line. A trend line is a line that tries to go through, a straight line that goes through a majority of the dots. So we're going to draw a line. Let's use red. Let's try and go through a majority of the dots, close to them as possible. That line is called the trend line. The equation for the trend line is called the line of best fit. So looking at these two up here, which 2 points do you feel fall closest to our trend line? Okay, so we are going to use 1960 and 2000 as our points. All right, so now I have 2 points. I have the point 1960 and 31,000. And I have the point 2,000 and 4,200. Or no, 42,000. What am I saying? Yeah, go ahead. The ones that fall closest to your line that you drew. So somebody might draw a line a little bit different than yours. It happens. It's fine. All right, so the first thing we have to do is we have 2 points, which means we find a slope, right? So y2 minus y1 over x2 minus x1. So 42,000 minus 31,000 is 11,000. 2,000 minus 1960 is 40. And you guys got 275? Okay. All right, so that's our slope is 275. All right, so now we're going to make an equation using our first point. So I have y minus y1 equals m times x minus x1. All right, so here's an equation. Now, we can distribute it and change it into y equals mx plus b. We can do a lot of different things. It's up to you guys. But we make this equation. This is our linear model. This is the line of best fit, and we call this a linear model because I can now predict how much money is going to be the average made in, let's say, 20, huh? 3,000. In 3,000? We're not going to be around to see that, though. Let's predict in 2060. You guys will still be around, right? So if I'm going to predict how much we have in 2060, I'm going to take 2060 and put it where? For x, exactly, for x. So I have y minus 31,000 equals 275 times 2060 minus 1960. All right, so 2060 minus 1960 is 100. So I have y minus 31,000 equals 275 times 100 is 27,500. And then I'm going to add my 31,000 to the other side. So I get y equals 58,500. Did I add that right okay in my head? I've had a long weekend. You guys check it. Nah, don't worry about it. It's fine. Now I'm going to hope that we make more money than that by then. But, all right, so that's a linear model. That's what we're doing today. Now, a regression line is the exact same thing, but we let technology do it for us.
Are there any, like, this big a number on?
Yeah. It'll be okay. All right, so we're going to learn how to use technology to do this exact same thing. So technology is going to actually write us our line of best fit. Technology is going to take care of that for us. All right, so here we go. Let's say I have a table, and no, I haven't even gotten to examples yet. I got to teach you how to do it before I can put examples down, right? So let's say I have, actually, let's just make a scatter plot. I'm just going to use x and y for now. And let's go with 0, 1. Let's go 3, 5, 5, 6, 10, 11, and let's say 11, 16. Okay. So we want to write a line of best fit equation for this data, for these points. All right, so the first thing we're going to do is in your calculator, I want you to hit Stat. The Stat button is right underneath the Delete button. So you hit Stat, and you go into Edit. Yep. Okay, so you should have some columns there. Does everybody see you have L1, L2, L3, L4, blah, 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 blah? I need to make sure everybody's good. All right. I want you to enter X values in L1. So in L1, you're going to put all of your X values. So you go 0, enter, drops you to the next one. 3, enter, 5, enter, 10, enter, and 11, enter. Then you're going to enter the Y values in L2.
So for L1 it's 0,
Mhm.
and then it's 3.
Yep, have to hit enter. All right, let me know when you guys are all caught up and ready to keep going. Okay, the next thing we're going to do is we are going to hit stat again. Push 1 to the right to calculate. And then you're going to go down to number 4, which says line reg. So then we go down to number 4, line reg. That means a regression line. Hit enter. It should say X list is in list 1, Y list is in list 2. Then it says it's got try that again. It's got store, reg, go down to calculate. So push all the way down to calculate. Hit enter. And it gives you data. It tells you what your A and B are. So our equation is Y equals 1.2 X plus 0.797. Well, you're going to know it by heart. Don't you worry, you'll know it.
Like, do you know, like, everything with a calculator?
Most of it. Okay, so questions on how we got there? Any questions where it's at? What do you need me to do? Okay, let me see.
I don't know what's the problem.
Oh, you're in a different, like, language.
All my letters or my numbers are like 0, 0, 0, 0, 0.
Yeah, you're in the Netherlands right there.
Why?
Let's get back to English, you think?
I didn't do it. Yes, she did.
There we go. Now we're going to get to calculate. Oh, wait, what did we miss?
Let's see, when I looked, it said Netherlands, but I didn't think that was like the Netherlands.
Oh, yeah.
What?
Did
Yeah,
you?
that's how it does. Anytime
Okay.
I say a number.
Okay, I got it. Hold on. Yeah, I'm taking care of it. What in the? Okay, I've almost got you. Just a minute. I just got a couple more things I got to change.
I don't know what happened.
It's okay.
Somebody likes to mess with things at my computer.
Come on.
How much have you said this before?
Huh?
Does somebody in that class? Oh, never mind. Because
All right. Go ahead and put those back in. Okay. Yeah. He might. Who knows? All right. So does anybody have a question? I want to make sure, Lexi, you get that in and you know how that works. Right? Oh, you rid of that noise. There you go. Okay. So now we're going to get into a couple examples so that you guys can try and use your calculator to find what it is we're looking for. So on your homework today, 7 and 8, you are simply plotting them and giving me describe the correlation. Super easy. Has nothing to do with your calculator. 9, 10, and 11, you're writing the line for the trend line. Okay? So you're writing the equation for the trend line, which means we can use our calculator to do so. All right? So the only ones you don't need your calculator for are 7 and 8, the first two. So, for example, here we go. Example number 1. This will be for questions 9 through 11. Write an equation of a trend line, which is the line of best fit, and let's go with, I'm going to give you some data here, and let's say we have 8 and 75, let's go 5, 62, 12 and 80, 10 and 85, 2 and 35, and 9 and 70. All right, so we're going to grab our calculator. We're going to go into stats. Okay. Now, you have information already in that when you go into edit. Listen very carefully on how you clear your list. You push up to where your L1 or L2 is highlighted, hit clear and enter. Do not hit delete, hit clear and enter. Okay, go over to your other list, highlight the L1 or L2, hit clear and enter. All right, now in L1 we can put our top line again. Put all our X values in list 1. So that's 8, 5, 12, 10, 2, and 9. Go over to L2. Once you have that all entered, you go back into stats. Push once to the right and go down to number 4. The equation you should get is y equals 4.58x plus 32.668. If you did not get that, tell me and we see if we can't figure out what's going on. All right, so do we have any issues at all? Everybody got it? You accidentally deleted L2. Okay, I got to go back through and put your L2 again. And it was too late, wasn't it? It's resetting. Just give it a minute, okay? All right, everybody else, we're good? Is that what you got up there? Yeah. Yeah, perfect. Okay, so you're going to write it as a line equation. So it says y equals ax plus b. You plug your a in and you plug your b in, and we're dead. Okay, so that's all you have to do for those. Let's go to example number 2. Example number 2, it is going to ask you to find a linear model, then predict the number in 2013. This is actually going to be 12 through 14. Okay, let's go, and I don't know this is the number of. Let's say this is year now. Before you start putting it in, there's something I need to talk to you about. So let's say in 2000, we're going to say we have 12. In 2000, yeah, you can write this down. That's fine. But before you put in your calculator, I want to say something. Let's say in 2004, we're doing 16. In 2008, let's do 22. In 2010, let's do 30. Okay? Now, when you are doing data with a year, Ben, you okay back there? Okay. When you are doing data with a year, you never want to put the whole year into your calculator. So, and they're going to remind you of that in your book. It actually comes out and says use, let's see, it says to use 0 for the starting number. It tells you right in your book, and it's reminding you of that. So we're actually going to use this one as 0. This will be 4, 8, and 10. So when I go later after I get my equation, I'm actually going to plug in what number? 13, exactly. All right, so let's go ahead. We're going to go back into stat. Let's see if we can calculate our equation. Why does what happen? Because it's going to make your numbers too much for the calculator to handle because the years are so much bigger. Okay? You go highlight your L1 and hit clear enter. All right, so the equation you should get is y equals 1.69. Let's go 695x plus 10.678. Did everybody get that equation? So now we're going to predict by plugging 13 in for what? X, absolutely. So we have 1.695 times 13 plus 10.678. You get 32.64. Yeah, that's what I got too. Okay? Questions. All right, so last 3 problems, 15 through 17, want you to decide on a correlation from words. So it's not even a graph. You're not looking at a picture, but I want you to think about this. Here, let's say your options are positive correlation, negative correlation, or none. 3 options. The size of your hat and your IQ. There's no correlation whatsoever, right? Let's say how you do on a test, the score on your test, and the number of hours you study. It is a correlation. It's a positive or negative. As the more you study, or the higher your score, the more you study, the highest score, right? Okay, do they have a correlation? Is that going to be positive or negative? Positive correlation, right? Okay, so that's all 15, 16, and 17 are. They give you a scenario. You just have to say positive, negative, or none. Questions? Okay, so you guys still have 10 minutes. That way you can get some of your calculator stuff done. You can always come back and borrow one if need be. Okay, you can check them out, but we can get quite a few done right now. All right, and I did post it in Google Classroom for those of you that like to use it that way. And of course, don't forget that the odds are in the back of the book if you want to check and make sure you're doing it right.
Is that why you have us do evens all the time?
A majority of the time, yes. because the answers to the odds are in the back. But see, I did this so that you can check and make sure you're doing okay, because it's something new. When we do new things, I want you to make sure that you can take charge of your own learning.